In search of more results, the team heads for the lab.
Hey Sam, how you doing?
Pretty good.
Good to see you
How are
again,
you?
Sam. This is Dr. Sam Iyengar.
Dr. Iyengar will be testing the samples of wreckage for any anomalies. This is the first time that this type of scientific precision has been publicly applied to a UFO investigation.
We'll take measurements off of these samples and look for anything that's anomalous, that's unexplainable. We had a number of soil samples from the site. We had a piece of metal, we believe it was aluminum, and then we had a piece of rubber that we also think was a fragment from the crashed aircraft.
Most of the material you can identify. You know, it's the question of whether it's anomalous or whether it's normal.
We ran a number of conventional metallurgical tests, standard in the industry, transmissive, X-ray. We're bombarding the sample with infrared light.
You look at the molecular vibrations.
We did a couple of X-ray diffraction measurements. We did scan electron microscope measurements. With this system, we're actually passing X-rays through the material. I think the tests we've run are comprehensive and they're the right tools for the job. We just need to get lucky and find a sample that has the evidence in the sample.
After completing the tests, the results show an interesting trend.
I took a little sample from the serrated edge of this aluminum piece and then analyzed it by diffraction method. And you can see here's the XRD pattern for it.
So the sample of aluminum generated aluminum and aluminum oxide.
Yes,
and
it's a corroded, yeah.
Aluminum oxide is the result of aluminum combining with oxygen, a chemical reaction that results from corrosion or exposure to a high-temperature heat source. All test results show that an extremely hot fire broke out aboard the B-25. This seems to go against another theory, that this was an explosion caused by the gas tank. Next, Dr. Iyengar analyzes soil samples collected by the team from around the crash site.
Here are the X-ray diffraction patterns for the 4 soils. The one near the engine and 5 meters away from the crash, they look almost the same, you know, except why is it sharp? The sharpness in a diffraction is due to the increased crystallinity. One of the ways of increasing the crystallinity is heating.
The crystallinity of the sample underscores how intense the heat was and how all 4 soil samples were affected. But the bigger question still remains. What might have caused the fire that brought the plane down?
If someone simply tells me, oh, maybe there was a spark on the plane, okay, well, I have questions then. You know, how did the spark happen?
Is it possible that this alleged slag material, through some sort of intensive radiation or magnetic field or thermal event, could have brought this airplane down? I'm not sure. We're going to go back to the lab and run some tests.
The team heads to the lab of researcher John Tyndall, who demonstrates how a piece of metallic slag could have a disastrous effect on the mechanical and electrical systems of the B-25.
This is a very close approximation of what that slag might have been or might have looked like. And because it has some ferrous metal in it, it could be magnetic. Well, what we have here is a relay, such as you might find on that airplane. In fact, there's probably dozens of them on the airplane. Now, if they set that slag down or moved it during flight, it's possible that a magnetic field could come and defeat the relay.
As the magnet approaches the relay, the switch fails. If the reported UFO debris was magnetically charged, it would have affected multiple switches and motors inside the B-25. A failing relay could also put the B-25's electrical system in jeopardy.
Now, the B-25 had 120 amps of power to run everything from the turrets to starter motors to whatever, and they all were controlled by relays. What we have set up here is a situation where we can create a dead short, such as if a motor or something went fluid.
So you're running 120 amps through a 20 amp circuit.
Meaning the circuit wouldn't be able to handle that it's being overloaded.
I think you can be the judge of that.
Oh.
As you can see, the wire was literally vaporized.
John has one more theory. He's demonstrated how highly magnetic slag could have affected both the electrical and the mechanical systems of the plane. But is it possible that the very composition of the slag itself caused the plane to crash?
All right, I'm going to use a arc welder to spark this slag off, much as might have happened that night with the B-25. Stand by. Okay, look.
Whoa!
Whoa! Wow!
So that is burning slag, and look at how it's smoldering.
Right.
Still.
Well,
would that burning slag be of a temperature that would eat through the aluminum on the
this
plane?
slag, it's around 4,000 degrees that slag is burning.
And aluminum melts at?
1,200 degrees.
Aluminum is one of the main components in the fuselage, skin, and wings of a B-25. A 4,000-degree fire inside the structure would be devastating.
If on the B-25 there was a short circuit, and the short circuit got to the slag, it's very possible that there could have been a reaction similar to this.
Is this the same type of aluminum that the fuselage would have been made out of, or the wings, or?
Same kind of aluminum. You know, these are all things that, in the right combinations, can be very combustible and have quite an exothermic reaction. Stand by. Look. Whoa!
Oh!
Whoa!
If the plane carried that slag and experienced an electrical fire at 4,000 degrees, you're looking at the result on the hull.
This fire was different from a normal fire or even a gasoline fire in that it was white hot. So this would have seared through any metal and caused a whole lot of problems on that plane. It's one thing to hypothesize, well, it could have been this, and it's another to see it with our own eyes, that yes, you can spark slag. Slag can produce a combustion, an explosion, which can burn through metal, which would lead to something like the crash of a B-25. And one of the possibilities is that we're dealing with UFO debris that may have caused this crash.
So, gentlemen, we are back from Tyndall's lab. We're back from Kelso.
Although we weren't allowed to dig up all the wreckage, we were able to dig up some really good debris. And we were able to really determine that a fire could occur. You know, there was a reason that this plane could have caught fire.
So of all the evidence in the case, the samples that Pat found while scuba diving are definitely out. But the samples we were able to analyze in Dr. Sam's lab, obviously we didn't find any smoking gun, that there was definitely some sort of UFO or extraterrestrial involvement. But on the other hand, nothing to disprove that.
Nobody's really been to the site over those 60 years after the Air Force cleaned it up. We were there, we retrieved material, we tested material, we found reputable scientists to evaluate the material. We reconstructed the final moments of the crash of that B-25. We're bringing science to ufology. Speculation out the window, science right here.
Many samples proved inconclusive, but experts say there are definite signs of anomalous activity surrounding both the Maury Island UFO incident and the Kelso crash site. What really happened may never be fully known, but witnesses are certain that something took place in the Maury Island Sound one summer's night in 1947. Did it cause bodily injury to witnesses? And was it enough to set off a chain reaction that resulted in the deaths of 2 Army pilots? The mystery continues.
In the world of UFO reports, you got 90% of them total bull, okay? Either delusional, either out-and-out hoaxes, or honest mistakes. Fact is, there are 10% that are absolutely real. We will find it because it is there. And when we find it, we will prove it.